In this video, we're going to talk about how to design a constant current LED driver PCB using Altium Designer. Hello, everybody. Welcome to another episode of Electronic Savvy. In this episode, we're gonna take the same constant current LED driver that we calculated, designed, and simulated in the previous two episodes and are going to capture the schematic and do the layout and design a fully functional PCB or printed circuit board to verify our design. So in this episode, I'm gonna walk you guys through how to set up your Altium, how to create a new project in Altium with a schematic and PCB files. Once you guys download Altium, go ahead and click on Files right over here. And you're gonna go to New and then hit Projects. And then you're gonna click on PCB project where it allows you to create a new project, new PCB project. So we click on this, Altium creates you a new project. It gives it a very random name, in this case, PCB_ project 1. Right click on it. And then you see a couple options. So the first option is to add new to project. That's the first time we're gonna create this new schematic and PCB file. So we're gonna go to add new to project and then hit schematic. Altium will add this schematic sheet to this PCB project that you guys created. Similar thing, you guys just gonna go here, right click, same to add new to project. And then this time we select a PCB. Now Altium is gonna add a PCB file to this corresponding PCB project, right? So now we have basically our PCB file. If you guys are interested, I can make another video for kind of step-by-step beginner guide on how to really design PCBs and how to work with Altium. Now Altium automatically created this for you. So what you guys need to do is, in order for Altium to know that you have a design where Altium can track it, you need to save this file. So again, you basically, all you do is just, go to this, sheet 1 and then just save. Just make sure that where you save schematic sheet, it's the same local folder as the PCB project as well as the PCB doc. I went through the exact same steps as I just explained, where you added the schematic sheet and the PCB document. So in the schematic sheet, we're just gonna open it, and here are schematic. So now we're gonna fill it up with the same circuit that, again, we designed and simulated last week. So the first step is to place these parts. You could just go to the place right over here on the top, and then you just hit part, right? So place and then part, and this basically little sidebar kind of pops up, right? Over here, basically what it's trying to say is you can select different part numbers on these libraries. When you guys get Altium, you probably won't have these libraries. These are the libraries that I basically created or I integrated with Altium. Again, I can make another video where I explain how to create libraries in Altium, how to create schematic libraries, PCB libraries, and how to integrate new libraries into Altium. So in this case, since I've already made these libraries, all I'm gonna do is just go through the library and select the part I need. So for this particular example, I'm gonna select the library I need. So the first one is going to be this part. So what you can do is you can either drag, like if you just hover over here and then drag this part, it'll come out here, or you can just double click and then Altium allows you to, just take it, move it around, whatever you want to do with it. So we're just gonna press your left click, you'll, you just left click on your mouse and then just place it. Again, you can just place as many as you want. This is the first part. The other part is the 1 kilo ohm, and then our resistors for the current sensing as well as the base of the NPN. And also I'm gonna just, pick one input capacitor, different voltage ratings, different capacitances. So you guys basically can select whichever you want. I mean, in this case, I'm just going to select this guy, which is a 50 volt tantalum capacitor with 33 microfarads. So I'm going to select it, drag it over here. That's my input cap. And I'm going to go look for input connector, right, in order to connect it to the power supply, right? I'm going to search for header. Here I have a couple options. This one is a 4-pin, this one is a 2-pin. I'm just going to select, simple 2-pin header for my input. And let's say I'm also going to, select the 2-pin header, let's say for my PWM input from the micro, right? And the last one is our transistor, right? If you guys recall, we used a 2N2222 transistor, NPN transistor. And I've already had a part number for this, so I already had a part added to Altium. So I'm just gonna double click it, drag it, and put it right over here. And as you guys recall, we had 2 of them. All right, so these are our parts, right? So now what we're gonna do is we're gonna rearrange these, put them together, and complete the circuit. And we also can't forget about the LED, right? And here I've got the LED. I'm just gonna place it right over here. This one is a green LED. Okay, so now we should have pretty much everything we need to start the design. All right, so we're just gonna move a couple things around. So as we said, we have the LED connected to the collector of this NPN. And then we had this resistor. I mean, this resistor is a 33 ohm, which will limit the current, the constant current to about 21 milliamp instead of the 35 milliamp that we calculated. Again, this one is the one that I had readily available in Altium, but since it's a generic footprint, again, it's a 0603 footprint, it's an SMD surface mount device footprint, we could basically just swap out that part number for 20 ohm or any other resistance values if you want to. So for now, I'm just going to select this 33 ohm. We're going to place it right here at the emitter of this transistor. And then again, same thing with this transistor, as you guys recall, same thing applies. So we're going to click X, and X will again flip this component from one side to another. So we place it right here. Move this capacitor over here, and then the same kilo ohm resistor is going to be the same thing. Again, to rotate a part in Altium, we're going to use the space. If you hit space bar a couple times, you should be able to rotate it 90 degrees every time. We're going to place it right here at the base of that transistor. We're going to move these input connectors a little bit to the left. So now we have basically our general circuit pretty much done, right? So what we're going to do is we're going to space these out a little bit more to make our schematic look a little bit nicer. And now that we have everything placed in approximately the right area, we're going to start connecting them. Again, same as LTSpice, using a wire, right? So in order to connect components in Altium, all you need to do is you go same to place right over here. And then you're going to hit wire. As you can see, there's like wire. You hit wire, and then this little sort of a cross shows up on your schematic sheet where you can connect things quick. So again, as I said, one way to connect a couple parts together is to go here to place and then wire. There are a couple other ways. One way, and again, as it says here, right in Altium, kind of trying to suggest you that you can use Control W. So if you do Control W, you should be able to, that same wire command pops up. That's one way. The other way is to hit P on your keyboard and then hit W. That also activates interactive routing, basically a wire. And the other way, the last resort is to use this little box over here that you guys have, as you can see. That's pretty straightforward. You could use this, as you can see over here, there are a couple options. One is, the power port, you have like harness, you have ports, you have other things that we're gonna get to in just a sec. But just to use the wiring, you could just hit place wire. Again, same thing here. You could just hit place wire and same thing. So Altium offers pretty much a lot of ways for you to connect components together, but also it makes sure that it enables you to use as many shortcuts as possible. Again, that makes the whole routing effort much easier. So now that we connected everything, we need to make sure that we can supply power to the circuit and we have a return path. Altium, again, is the same really as LTSpice in the sense that you always need to have a source and you need to have a return path. So the way that we're going to do it in this case is slightly different. Obviously, this one is more real right? And this one is actually going to be a piece of printed circuit board electronics that we're going to power up and we're going to see how it works, which is a little bit different than simulation. But again, the same idea really applies here. So we need a power source. Again, for power source, as I mentioned, we're going to use one of our connectors over here. We're going to go here. We're going to place some wires right over here and then right over here. And then we're going to move this guy right over here. And as you can see, I can just zoom in and you see that once it'll basically snap right into the end of this wire. So now this is connected, and then you bring it back right here. You're just going to line it up with the other connector. The way that you do nets is, again, you go to place, same thing, and then you scroll down, you go to net label. It's just called net label. And then this little net label kind of pops up. So in here, let's say we're going to change it to something that makes more sense in our case. You could hit the tab key on your keyboard to pause the screen. As you can see, it literally paused the screen. And then now you could interact with this little sidebar where it's the properties of that net that we just selected. In this case, for net name, let's just call it VN as it is. You know, that's basically our VN, or we could just call it VCC just to stay consistent with the simulations and calculations with it. So we're going to hit it VCC. And then again, you have the VCC. You could just place it right here. And then for this guy, this is going to be our ground, right? So we need to have a power and ground in here. For ground, again, this we talked about it. This one is pretty straightforward. Altium already gives you that ground power port. So it's already pretty straightforward. It's right over here. So now we have VCC and ground. And again, this is since this is a real world, a practical example of our circuit, we should have some sort of an input capacitor like I have in this case, just to make sure that we have enough current, basically instantaneous current for powering these electronics. Again, this is not so necessary if you're just using bench power supply. But again, here, just since we want to make sure that we cover practice of designing circuits such as these, we should probably have some sort of a capacitor, input capacitor on the input before feeding this VCC to our LEDs and other electronics in this board. Now we have the VCC, and then same thing, since we discussed that this VCC, again, we copy it, it's going to be what drives this LED. So we're just going to hit it right here. And again, as you guys saw, I just basically hit the space bar to rotate the net. Again, that space for rotating, that works for any parts or components on the schematic. And here, again, for this, so this one is pretty much done for the power. And then as you guys recall, for this side that drives the main transistor, we said that we can basically have it either directly connected to VCC, or we could have it hooked up to the micro, one of the GPIO pins on the microcontroller. In this case, we're just gonna use, let's say, just an input connector that we could use it for any purpose. We could hook it up directly to a microcontroller, or we could hook it up to another power supply, or we could just hook it up to the same VCC. Just to give us a little bit more flexibility, we're just gonna make sure that this design is as widely used as possible, right? So we're gonna do the same thing again. We're gonna do PN for the net. We're gonna hit tab to change the name. Let's say in this case, we're just gonna PWM in this case. Hit it here. And then again, if we want to connect it to the micro or to a power supply, we do need to have, again, the same return path. So we're going to use the same ground. We're going to place it right here. And then same thing, wire, connect the other pin to the ground. So now we still need to have this ground for our main circuit. So now that's pretty much the circuit. It's pretty much done. We have our input cap. We have our LED, transistor, current sense, the transistor that controls the base of the main transistor to ensure constant current, and this kind of a base resistor that, again, if it's connected directly to a microcontroller, it's not really necessary, but we put it, again, to limit the current through the base of this BJT. So now the second step is to name these designators. As you can see, there is that little wiggly line right underneath these two connectors and also other parts. The reason for that is Altium is telling you, hey, there are two parts with exactly the same designator. The way that Altium distinguishes parts from each other is using these designators. So if the designator is identical, it is basically confusing Altium debugger, and it basically flags it as an error. So you just don't want to, obviously you don't want to have the same exact designator for two different part numbers, right? For two different parts that have nothing to do with each other. Again, same thing here. You have this R question mark, R question mark. They're obviously completely different parts. So what we need to do is we need to rename them. One way is to just go here, just go to every single part. If you double click, this tab sort of pops up with all the properties of this particular LED in this case. And as you can see, there's a designator box that has R question mark. So you could change that, let's say, to D1, right? Just to say consistent. We call it D1. So now we change the designator to D1. You go through every single part and make that change. So that may sound a little bit tedious, right? So the better way to do it is to go to your tools and then go down to annotation. And then in this box, if you just go down, the fourth option, there are a couple options you could just go and annotate, but the one that I really like is annotate schematics quietly. So what it does is Altium automatically goes through your schematic and it automatically assigns perfectly lined up designators. Now, as you can see, Altium automatically renamed these designators. So imagine that if you, this is a simple design, but if you have a much more complicated design with so many more parts, you definitely don't want to go through every single part and change the designator as it is very tedious. So now that we've done this, it's pretty much the same exact design as the design that we hand calculated and the design that we simulated in LTSpice. So now what we do is we need to move this design from schematic to the layout, to the actual PCB layout. So how do we do this? We go to design, and then it's very straightforward. The first option, it says update PCB document. It just gives you which PCB document. If you have multiple PCB documents, it will show here. There will be like 2 or 3 options if there are multiple PCB documents that are associated with this schematic. So you could make that change. But in this case, we only have one PCB, so we're just gonna hit this. And then Altium is gonna go through a couple checks to make sure everything looks good. And then when it asks you about this, it's just saying that there are unique identifiers. I haven't found a match. Is it fine if I automatically create component links? And you just say yes. Automatically, notes to update. And right over here, yeah, I accidentally had another part in there. We don't have to worry about that. And then here we have a bunch of parts. Again, it's removing that part that I accidentally placed, but now it's going to add a couple parts which are shown here as C1, D1, J1, and then these are the nets, and this is the schematic file. And here Altium usually just add the room. I like rooms when you deal with large designs where you have power supplies, you have a microcontroller, you have analog circuits, you have digital circuits. So room kind of helps you place different schematic sheets all together. Imagine that you have 50 parts and 5 schematic sheets. So you want to be able to sort of separate them by each schematic. And the way it does it is just using room. So like all the parts in one schematic sheet will show up under one room. In this case, again, this simple, we don't need this, so I just kind of uncheck this guy. Go with execute changes. So you hit execute changes, Altium gonna make these changes. It'll remove that component, add a couple other components, and then it goes through this list one by one, and then now it's pretty much done. So you hit close. Now, if you zoom out, you should have the parts right under here. As you can see, we have these parts fully moved from the schematic sheet to your layout, to your PCB. So this particular board is a simple 1.6 millimeter board. You could go through this layer one by one using your mouse. You can just click on each of these layers. You can see they're changing. The top layer is the one that we use mostly for, to place components. The bottom layer is usually for, ground pores. So one way is to click through each of these layers with just your mouse. The other way, the faster way, is to use your plus and minus keys on your keyboard. So if you just hit plus, it goes to the next layer, next layer, next layer. If you hit minus, it'll just go to the previous layer. And then if you hit minus, on the topmost layer, it'll go to the layer at the very end of the list. So now what we do is we're going to define our board shape. So how do we define board shape? For this particular design, again, I'm just going to use our keep out layer to define the board outline. Go to place. And then we go to keep out. And then we go to track. Track. This is not a electrical trace. This is just the keep out layer trace or track that will define our board outline. Just hit the left click, just place it, and then I have it as this little rounded edges. But the way that you could change it is if you hold down shift and then hit space, that edge, the edge of the board, as you can see, like this little edge, you could change it to different shapes. You see, you could just change it. You have this round one, you have this right angle one, and back to this. So yeah, I always recommend guys to basically keep this round edge for your boards. Again, this will help. Obviously, there's that kind of a safety feature to it where you don't, like, it's not too sharp that it will, cut something, but also it just helps with manufacturability of this as well. So we're gonna just do this, hit again, very rough outline. Again, very rough board shape. It doesn't have to be just like that here. And then we're gonna go here. Let's say here, and now this one just came a little bit, zoom in, drag it, place it, boom. So now we define a board, but obviously the board shape is still this huge piece of PCB, right? We're gonna change that. So what you do is you go again to this keep out layer, and then you only show the keep out layer and hide everything else. The way that we do it is if you hold down shift and then hit S, everything grays out except that layer that you're in. In this case, our keep out layer. So now if I drag this box around it, it only selects my keep out layer tracks. And that's what I want. So when I select this keep out layer tracks, which is my board outline, you go to design, board shape, and define from selected objects. This one will only grab onto the tracks that are selected as our outline. In this case, this keep out layer lines, basically. So we selected right here. So now our board looks much nicer. That's much more reasonable. We have a relatively smaller board, which should be able to fit all these components with ease. We're gonna go back to the 2D, and then as you can see, this little X basically shows the origin of our board, and this one is way off. So we need to fix that. So we go out here, and then we're gonna go to edit, scroll down to origin, and then say set. And we're just gonna set it like right over here, somewhere at the basically bottom edge of the board. This will ensure that the board is centered out properly. Obviously, that will basically make sure that our DFMs are not too off from the real board. So now that we have everything set up, we're gonna place everything around. So as you guys recall, the J1 was actually our input power connector. So every time you do the board, always try to have a vision on how really the current really flows. So usually in most boards, current always flows from the input, let's say the left side of the board, to the output on the right side of the board. So always try to have your input parts, input connectors, input caps, any input protection, let's say TVS, ESD diode, just make sure that they're all on the left side, and all your outputs, like LED in this case, are on the right side, like the output side. This LED for this particular application, this could be anywhere. It doesn't have to be on the right side. For this design, we just want to keep the input and output separated and have a vision on where the input is, where the output is. So let's keep the input on the left side. So we're gonna again drag this guy. Same thing with the space bar. You should be able to rotate it. So we rotate it. Let's say we're gonna keep it right over here towards the center. And then as you guys recalled, we have this input cap. Always try to have your input cap very close to your input connector. This will ensure that if there is any noise or if there are any interference on the VCC line, it'll get filtered out way before it gets to your LED or it gets to your transistors or anything else. This is a very simple design, but for example, if you had components such as microcontrollers or ADCs or some of the other components that are more prone to noises or to interference from devices upstream, like in this case, the VCC, it's always best to make sure that they're immune to those noises by implementing the right noise reduction techniques, such as using these input caps, decoupling caps, and things like that. So now that we have the input caps are connected, we just got to go through the same design, making sure that everything else is placed properly. Again, this PWM, we're just going to move it over here. And then we had that LED, like let's say in this case, again, this LED, just going to zoom in. This one is a pretty tiny one. Just going to put it, like let's say, right over here, right in the center. One more thing that you guys should know is if you hover over one of the pads of any of these components, and then if you hold down Shift, it'll highlight that particular net. And then if you hold down Control and Shift and click it, it'll highlights it and it basically dims everything else. So it's easier for you to know where other parts are. Now everything is pretty much settled. One other thing we could do is we could just change these to move it down, move a little bit down, and then make it a little bit more symmetric, right? So it looks a little bit more appealing to the eye. We go here doing the same thing just to make it a little smaller. Oops. Boom, and the same thing, we go to a keep out layer. Same thing. So now that everything, as far as the part placement goes, looks pretty okay. So what we do next is to connect the parts. So now we need to go back to the 2D view and connect everything together. So there are two ways that I usually do my layout. The first way is to connect the parts, connect these components using, we call it tracks. So in order to route traces or route tracks, you need to go to the correct layer. These components are all placed on top layer. So we need to go to the top layer if you want to connect these components. These parts where they have through hole, again, this is a through hole component, right? So it has these holes. And as you can see, these gray pieces indicate multi-layer. Again, we saw it over here, that multi-layer. Multi-layer means that you can connect these components to anything on the board using any layers. Obviously, you won't be able to connect to anything. You can connect these parts to the corresponding component using any layer. It doesn't have to be top, it doesn't have to be bottom. But in this case, we only have two layers. We have the top or bottom. So we could use that to connect these particular nets, these particular holes to these corresponding nets. So now what we do is we're gonna go to top layer. We're gonna again, same thing. We could do trace. We do trace and then connect them. As you can see, this one because it's interactive, it automatically changes the angle of that routing and it connects it to the pad. So now you could change this interactive routing. So you could hit tab, and then you could change this width to anything you want. Let's say you want to change it to like 30. So when you change it to 30, it just makes it a little bit thicker. So that's one way. The other way is to connect these parts, connect these components using regions or polygons. In this case, for all the input powers and high power boards, I tend to use regions because regions allow you to put areas of copper on your board, which helps with thermal dissipation and with higher current conduction. So that's always a plus. So what we do, the way they do it is same thing. You go to replace, and then you just hit solid region. If you solid region, this little thing comes up, and then you could just create this shape. Again, same thing applies here. So if you hit space, you kind of change the sort of a vertex of it. And then if you hold down shift and hit space, it changes the shape of that angle. And again, when you connect a couple things like that, it'll just auto fills it, and then it just pours it just like that. So what we're gonna do is we're gonna again do the same thing, go to regions, connect them, connect this VCC right over here. We're gonna connect them right here. And then we're gonna go down here. Boom. Bada boom, bada boom. Awesome. So now that we have our VCC, it still kind of doesn't show as connected. It's because this region or this copper port that we just made here has no net. It says no net, right? So you need to go here and then hit VCC, and it gives you that option. So if you hit enter, VCC, if you hit enter, now this LED is connected to the right net using this region. Again, we're just gonna do a little adjustment just to make sure that we have the right amount of copper here. Same thing. So I'm just gonna go through this real quick and finish it. So now everything is pretty much connected. Now the only thing that's left that we need to connect is just the ground. Usually the way that I personally like to connect grounds is to create a way for current to return in the fastest and shortest length possible. So what's the shortest length? The shortest length for this current at ground to go back to this ground, let's say, is through a via. So how do we place via? So a via, again, you go up here, you place via. You have this guy. I'm going to place it as close as possible to the pad without really having this brown piece touching this red box. I'm just going to go here, just going to place it kind of around, making sure that that ground doesn't really touch. Again, I'm just going to put a couple around it. We can definitely talk about why putting vias next to these pads are beneficial in terms of EMI and other power electronics topics. That again, for this circuit, it really doesn't matter because nothing really is switching. But in switching regulators, it's always best to practice placing vias very close to the ground pads to ensure the shortest return path for current. And we're going to place it right over here at ground. Same thing for this guy. And then that's it. So now that we have everything connected, so now we're going to basically place a polygon. So how do we place a polygon? The way that we place polygon is we go to place, and it's always recommended to have ground polygon on both top and bottom layer. And the reason for that is to ensure that there will be the shortest path for current to flow. Imagine if you have ground all over your board, what happens is that current that you're conducting from one component to another, it'll have an easier time and a shortest path to go to another layer and go back to the supply, to the return current, and ensures that there will be the least amount of electromagnetic interference or any other ringing issues when it comes to higher power and switching regulators and switching designs. In this case, again, it's pretty straightforward. We're not going to really worry too much about it, but still it's a great practice to pour ground for rigidity and reliability of this PCB. So we're going to put ground for both layers. The way that we do, we go to place, we go to ground, we go to polygon pour, and then again, the same thing applies here. We have this little guy. We're gonna just do the same way that we did the keep out. Boom, and then once it pours, we just go no net. Again, same thing, change it to ground, connect, and then we're gonna copy this, just Control C, very simple. And then I go to the bottom layer. One way is to just do Control V, and then you have this and you could just place it. But the only thing is, if you do that, this pour that you'll have don't really show up as bottom layer, it'll show up as top layer. It doesn't pour in bottom layer, and it doesn't have the ground net name. So the way that you can avoid that is we can go to edit and then paste special. If you hit paste special, again, the same thing pops up, paste special. We want to paste this ground pour on current layer, which is bottom layer, and we want to keep the same net, which was ground. So we're going to hit paste, and same thing, it pops up, and then we go here. That was the location that we copied it from. And when you hit it, it pours it right here. Now it's not here because it hasn't poured yet. So what Altium does is every time you make a change to your polygon, it'll shelve it until you pour it back again. So the way that you pour your polygon is you go to tools, you scroll down, you go to polygon pours, and then you just say we pour all. When you report all, everything is reported again on top layer. This is your ground, and bottom layer, this is your ground. And one recommendation that I always give people is try to via stitch your layers. If it's a 2-layer board or if it's like a 10-layer board, try to via stitch your layers, because this will lower the overall impedance that you see across your input, because this will ensure that you have the smallest possible loop and the smallest possible length for current to flow from plus to minus or to the return. So the way that we do via stitching is you go to tools, scroll down to via stitching and shielding, and then you say add stitching to net. You hit this box will pop up, and then it kind of gives you a couple properties of that via that's going to pour. It's going to be a 15 mil hole size, it's going to be 25 mil for the diameter, and grit is going to be 100 mil. You could have 100 mil, you could change it. It's basically mean what's the center to center distance from one via to the other. It could be 100 mil, could be anything. You could just push it like 60 mil if you want to have more, vias on the board, basically. But I mean, 100 should be fine as well. And property, which is the most important piece, you just need to make sure that it's a top layer to bottom layer, because you have the top layer as ground and bottom as ground. And obviously the net must be ground. So we have ground, and then when you hit OK, it'll just pour ground all over your board. Now you stitched the top and bottom layer together. And now here we go. So I just kind of move a couple things around. I finished up the via stitching, put some text on there, and I put these mounting holes just for if you want to mount a board in a package or in a housing or something. This will help. This is the board. This is how it looks like. Thank you guys so much for watching. Please let me know your thoughts, questions, or any recommendations. Please put it in the comment. Don't forget to drop a comment, and I catch you guys in the next video. Peace.